Hello everyone, welcome to Coders Camp. I'm here with another interesting problem from LeetCode, which is partition labels. So the input given here is a string and we have to return an integer array which represents the size of the substrings. So the problem statement says we are given a string yes and we want to partition the strings into as many parts as possible so that each letter appears in at most one part. Note that the partition is done so that after concatenating all the pods in order, the resultant string should be yes, which means if we are separating them as substrings, we should not leave any character out of the substrings we divide them into. And we have to return the list of integers representing the size of these parts. So let's understand this with an example. So here is our given input string yes, and we have to return our output in form of integer array. The problem statement says that we have to divide the given string into number of substrings, and finally if we combine the substrings we have divided, then that should result in the input string yes. So now the condition says that if a character is present in a string, then one substring should have all the characters in it. Let me put it this way. So if suppose we are starting our substring with the very first character A, then the substring S1 should have all the A's in the given string, which means it should have this A, and this A as well in string 1. We don't have any more A left in the rest of the string. So till here, or possibly it could be longer, but at least till here, our string S1 should be, because that only will hold all the A's present in the given string. So let's divide the string first to understand the problem statement better. So here are the substrings we have divided by considering the problem statement. So clearly from here we can decode the problem statement mentioned that each character should be at most in one substring. So for example, if you see A, we have started our substring S1 with A. So this substring will have all the A's from the given string. So here A, and till here it has covered all the A's in the given string yes. Same way if you consider B, so it had covered all the B's as well. So there are two more B's in the given string and no more B's in the second half of the string. So that has been covered as well. So again A, and there is C. So let's check if there is any C left after this character. So if you see, there is one more C here and there are no more C's left in the string yes, which means this string has covered all A's, B's and C's in the given string. So that is what the problem statement says, that the substrings should cover all the characters within itself. No more characters should escape to other substrings. So again, similar to substring 1, if you see substring 2, we have D, E, F, G, everything covered inside. You won't find any of these characters left in the rest of the string. Same way, H, I, J, K all covered in this string S3. So if you combine all three S1 plus S2 plus S3, you will get the input string yes. And we have to return only its length. So the length of the first substring we have divided is 9, and the length of the second substring is 7, and the length of the third substring is 8. So hope you are understanding the problem statement now. So let's see how are we going to approach this. So as we have understood, we have to cover a character's all occurrences within one substring. So in order to complete that, we have to first find the last position of any character in the given string so that we can think of where we can accommodate all its character within it. So now if you see our yes starts with, that is string starts with the character A. So we have to first figure out what is the last position of A, because by using that we should determine our first substring's length. So if you see, there are 3 more occurrences of A in given string yes, and 8 is the last position of A. So we are updating A with 8. And if you see, we have 3 B's and 5 is the last position of B. Same way we are updating the last position of all our characters in the given string yes. So this will help us to determine where our string yes1 should stop and other substrings should stop. So let's start with iterating each and every character and let's check whether we can accommodate all the characters within a limit. So let's have iterator I. at very first character A. So now we are going to iterate every time and update our variable j with the highest possible value. So first we are iterating with our A. So we have to check what is the last position of A and update our j, which actually meaning to what is the last position of A says that till that at least our first substring should be, because we have to accommodate all A's within this string. So far our length of our substring is going to be 8. So that is what J indicates. J is nothing but so far the size of our substring. So we could put it that way. Yeah. So now j is equal to 8 or I is equal to 0. So now let's iterate to the next position where I is equal to 1. So now our character is B. So we are going to check what is the last position of B. So if this B is exceeding this already existing 8, which means we should extend our length of our substring, because we have to accommodate all the characters within itself. Already our size is 8, so in this case we have to accommodate B as well. So in that case we have to extend our length of our substring. So obviously 5 is less than 8, which means we can accommodate all the occurrence of B within 8. So we are sticking with our length 8. So let's move to our next iteration, which is having the character A again. So if you see, A has already been covered. The maximum length of A is 8. So we don't have to change our substring, because within 8 we can accommodate all our length. So next again it is going to be B. So we have covered B already. So which is 5, which could also be covered within 8. So our next character is C. So C is such a new character, so we have to check its maximum last position. So last position of C is 7, which means we can accommodate all occurrence of C within 8. So we don't have to adjust our length. So till now our length is going to be 8. So the next character is B. So now our iteration is that I is equal to 5. So now check B is equal to 5. We can cover B. So now I is equal to 6. So we did not reach A's largest position, but we have 8 already, which will cover all its occurrence. So the next character is C, whose last position is 7. So which will also be covered by the length 8. So finally we are moving to the actual iteration I is equal to 8, where we have reached the last occurrence of A. So now we have reached last occurrence of A, which is 8. Our J is also 8, which means we have reached the last position of our substring 1. How do we say it? Because our j is equal to 8. This is the maximum length we have fixed for our substring 1 so far. So we have our iterator also have reached 8, which means we don't have any more characters that fits in this substring, and we don't have any more characters that goes beyond this substring. So whatever is present within 0 to 8 is present within this substring only. We don't have its occurrence outside of this substring. So we determine our result of our first substring is equal to of length 9, because our position is 8 but our array is 0 indexed, which means our length is 9. So we are adding 9 to our result array. So sticking with this, we are going to start our iteration fresh from the index 9, because we have found a substring 1. So we are done with this string and its characters. So we are going to start a fresh iteration with new characters. So now going on to our iteration with D. D is equal to at position 9, or I is at position 9, and D's maximum occurrence is also 9. So now our J is going to be updated with 9. So we can fix a character by only this, but let's continue and check the next character. So our E is at position 10. So we are going to check if its last occurrence is going beyond 9. So its last occurrence is at 15. So it's time to update our J to 9. Sorry, to 15. So with E's last position. So J is equal to 15 now. Moving on to our next iteration, F. So F's last position is 11, which will be covered within 15. So we are moving to E. E's last position is 15. G. G's last position is 13, which will also be covered within 15. So next character is D. D's last position is actually 14. I have updated it wrong here. So 14 will also be covered as part of 15. So finally we reached E. E's last position is 15. Our J is also 15. So which means we have reached the last position of our substring 2. So in this case, we have to find our length of our substring already, which is at 8. So 8 minus 15 is going to be 7. So we are updating 7 to our result. So we have done with our substring 2. Now rest of the string is going to be processed the same way to determine our uh, length of our third substring or any more substrings we have in our result. So now comes to the third iteration when j is equal to, we are iterating for h's last position is 19, so our j is going to be 19. So we are checking for i's last position is 22, which is greater than 22, so our substring is going to extend till the position 22. So now j's last position is 23, so again we are going to update our j is equal to 23. So technically j is the last index, 23 is the last value, so even if you iterate them, they are either going to be less than 23 or it is going to be 23. So finally our j is going to be 23. So let's do a negotiation from 23 minus 15, and the length is going to be 8, so we are going to update 8 here. So this is going to be our result string. And this is going to be simply achieved in a one-pass solution by iterating the complete string in one go and updating our variable j and subtracting the length and updating our result. So yes, let's go to the code now. So as I said, we are going to first keep track of every character's last position. So you can use any data structure as you like. Either you can go for hash map, or like I'm going to do, I'm going to use an array, character array, to keep track of the last position. So let me first declare j. As I said, we are going to fix our maximum length of string so far in this variable, and variable anchor, that is going to be our iterator to iterate our characters in a given input. So we are going to iterate our given string by character and update our variable j with the last position of that character. So we are going to check every time whether our j is equal to our I, which means whether we have reached the last position of our substring. If that is the case, we are going to update our result with the length. So anchor is a variable we move every time to the new position of the starting of our substring. So once we finished calculating our length, we are going to update it with the next character's index, because that is when our next substring's first character starts. So yes, that's it. Finally, our answer array list is going to hold all our lengths. So let's give it a try. Yes, let's run. Oh, yes, our solution has been submitted and it runs in 4 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.